Good afternoon, everyone, and welcome. I hope that you enjoyed that lovely music. We are so glad that you're joining us for Emerging Tech Brew Explorations, our first debut virtual event. I'm Ryan Duffy, Emerging Tech writer at Morning Brew. And over the next half hour or so, give or take, we are going to be exploring if algorithms actually know anything. So plenty of commonly used algorithms in production seem to know things, whether that's a cat or dog in your selfie or what new song to recommend to you. And these systems are powerful, but they don't actually know the answers to a question. They're very good at making predictions and finding patterns. But I mean, just what constitutes knowledge anyways? Isn't predicting someone's preferences a form of knowledge? Who even decides and defines these things? All excellent questions. And to close out our quarter-long Demystifying Algorithms series, we're bringing in two AI experts to try and help us answer these questions and more. Some housekeeping before we dive in. We want to invite all of you watching to please submit any questions that you have via the chat and question function, and we will try to get to a couple of them. So without further ado, I would like to welcome Dr. Mark Riedl. Dr. Riedl is an associate professor in the College of Computing at Georgia Institute of Technology. Dr. Riedl, thanks so much for joining us.
So great to be here. Thank you very much.
Yeah, so let's just jump right into the ambitious task at hand. From vision to language systems, we've seen the performance of AI vastly improving in recent years. I want to ask you, to what extent are these deep learning systems pattern matching and making predictions and getting much better at that, as opposed to exhibiting a fundamental level of understanding, let's say?
Yeah, that's such a great and hard to answer question. So what you said when you introduced this was absolutely right. These are pattern matching things. They take lots of signal, lots of data, and they try to extract pattern. Then they act on these patterns to, whether it's to tell you there's a cat in your selfie or recommend the best book for you to read next. But I think when it comes to the question of what do they know and what do they understand, it's really I like to flip the answer around and say it's really in the eye of the beholder. If these technologies are doing something that's useful and fruitful, then maybe they do understand something. So I'm a professor at Georgia Tech. I teach classes in addition to doing research. And so this question of what do people understand comes to me all the time in my classes. So if I'm teaching a class about artificial intelligence and neural nets, and I want to ask my students, do you understand how they work? And of course, they tell me yes. So maybe I ask them a slightly better question. What's an activation function? And they might tell me such and such a function. Well, that seems to answer the question, but do they really understand? Maybe to really get an understanding, I need to ask them to put the concepts and the knowledge into use. Use a neural net, build a neural net to do something that hasn't been done before. Show me that you can construct it in some sort of new context. So the question of what does it understand is really only as good as the questions that we can ask. And to me, when I think about understanding and whether AI systems have human-like understanding, I do turn to humans and say, well, what humans can do when they understand something is they can manipulate these concepts. And they can take concepts that they learned in one context, put them into a slightly different context, and what they output, what you produce, still sort of makes sense. So Richard Feynman, who's a physicist, had this really great quote, which is, what I cannot create, I do not understand. And so creation is a process of manipulating thought. And manipulating thought means to manipulate a thought in a reasonable and non-random way does seem to imply some sort of understanding. But if I look at a neural net, right, and it says this is just a bunch of numbers, does those numbers equate understanding? I don't think you can look at the numbers and do that, but you can look at the output behavior.
Right. Okay. So along those same lines, in your own personal research, I know that you're working a lot on story generation and text-based adventure games. Without sort of getting lost in the multidisciplinary morass of defining and understanding what constitutes knowledge. How do you test for progress? How do you benchmark that?
Yeah, and I'll start by saying I work on human-centered artificial intelligence. I'm very interested in making AI systems do very human-like sorts of things, and storytelling is one of these. And I'm interested in storytelling, well, for two reasons. One is if I'm going to work on fundamental AI problems like common sense knowledge, or planning, or bias and safety in natural language systems. Um, you do it in a story and it's more fun. But also I get to work on these hard problems. And one of the reasons why thinking about stories has been a very fruitful way of doing research is because we can actually get at the heart of this question of understanding. So in the same way I had this example about, does a student understand a neural net, right? Does a does an AI system that reads some text off the internet, maybe it reads some stories or reads a news article. I also want to know what it understands about what it just read. And again, I can ask it questions. Did you understand the story? But when you turn the equation around and you say, all right, I to tell use what you just read and make something new. Tell me a new story. Tell me a new story about Little Red Riding Hood, or tell me a story about something like that. I want to see you manipulate these knowledge structures in slightly different ways. So I worked on fairy tales for a very long time. Then I stepped back and I started working on common sense stories. Like, tell me a story about going into a restaurant. Do you understand what it's like to go to a restaurant? If so, you can tell me a story about it. And boy, do you get to know what your AI system doesn't know when it sets out to tell a story about something as boring and mundane as going to a restaurant, and it gets all the details wrong, right? You pay the bill halfway through your meal, you get your drinks after your food. I mean, these are indications that the models that these neural nets have learned from reading things on the internet are not as complete as we would expect them or want them to be. So when I think, so how do we benchmark ourselves? Well, I think you have this, the first step is in anything is like, can you learn the boring and uninteresting stuff? If you can have a good model of boring and uninteresting stuff that, by the way, is important to humans, then that's the first step. The next step is, all right, well, now tell progressively more interesting versions of restaurants, and go from there. So can we force the AI system to, can we push the boundaries of what the AI system knows by asking it to create more and more inventive, yet still understandable stories? And we can do this in game playing as well. So play a game. Can you win the game? Well, can you win the game in a more interesting way? Can you play a slightly different game than the one that you were trained on? This is called transfer. Taking what you quote unquote might know and putting it into a new situation. What we're ultimately trying to do is we're trying to make sure our AI systems aren't memorizing things. Memorization is kind of a way of cheating on, you know, this question of understanding.
Well, I'm really glad that you kind of wrapped that answer up there, because throughout all of that, I was just thinking about the parallels with humans and these sort of questions that are entirely beyond the scope of this conversation, but just about sort of standard tests like SATs and whether those are, a fair test of knowledge. But let's stay on track here. You actually made your own test back in 2014 to sort of assess the progress of language models. And this has been a big running theme recently in our newsletter of this idea that NLP model performance is outperforming kind of the benchmarks and the tests that we use to assess them. Can you walk us through what it was like creating the sort of the Lovelace 2.0 test, and just comment for those of us looking from the outside in, comment at all about that state, the sort of mouse and rabbit game of models, tests, and how those are faring?
Yeah, absolutely. This has been a really important thing in the last few years. So, um, what you know about an algorithm or neural net or an AI system is only as good as the test you produce, right? So it's always dangerous to infer too much from a test. So if we ask a neural net to identify cats, what can you say? Does it know what a cat is? Well, it knows some patterns. It knows some aspects of what cats look like and correlations between parts of faces and stuff like that, right? You can't say anything more than that. So in 2014, there was a challenge that was put out to imagine a new form of the Turing test, the Turing test being the classic test of whether something is a broad intelligence or not. And I've been thinking a lot about this question of creativity and how creativity really correlates with intelligence. I didn't realize at the time, but what I was really thinking about was this was ultimately the understanding situation. So what creators do is they take concepts, very disparate concepts, and they blend them together and they combine them in interesting ways. So an artist can draw a picture of a cat, but an artist can also draw a picture of a cat with four robot legs, for example. And so, how do you take those concepts of cat and robot and put them together in some way that people recognize as sensible versus just kind of a random legs coming out of strange places where you wouldn't expect them? Um, so, this idea of tests that don't have definitive answers but require humans to come in and judge them. So, yes, that's a cat. Yes, that's a robot cat. Yes, that's a robot cat on Mars was really what I was going for because as soon as you start to write down the answers to a test, you mentioned the SAT, right? How do you learn? How do you train for the SAT? Well, you do a whole bunch of practice tests. Um, but at the end of the day, what you're just doing is you're learning to pass the test. You're not, you can only make so many guarantees beyond that, right? So tests without answers was what I was going for. So the Lovelace test was to say, well, can we push an AI system ability to blend concepts together further and further and further? Where are the boundaries of where it understands how things mix together, right? So this example of a robot cat, right? Maybe you can draw a picture of a robot cat, or maybe you can tell a story about a robot cat. All right, so you passed that test, but we're not done yet. Tell me about a story about a robot cat chasing a mouse on Mars. Okay, can you draw that picture? If so, and if a judge says you can pass that, all right, that's two challenges down. Third challenge, let's add something else to that mix, something kind of unusual. And you just kind of keep adding concepts and concepts that have to be mixed and matched into this picture until the system only kind of falls on its face and just cannot keep up with the concepts. And now we can count the number of rounds you can go as evidence of how far we're able to push the ability of the AI system to manipulate its knowledge before it can't manipulate them anymore, before it comes up with the boundaries of how to manipulate these things. So that was the idea behind the Lovelace test, right? As a way of getting human judges to push and push and push until the thing breaks. It's like a stress test for understanding.
Understood. It's really interesting. So we are kind of running up on time here. So I'm going to do a dealer's choice. The last question that I had prepared was sort of this about narrow versus general AI and whether the transfer from today's systems, which are superhuman at one single very specific domain to a more general sense of AI, whether that would constitute a large, like a kind of milestone level up in understanding versus being just like, a continual step function of progress, or a reader question that I just picked, which is the lack of emotional intelligence that is brought to computational decisions a positive thing and why? So I would imagine you can't probably answer both of those in 2.5 minutes. So I'm just going to let you choose.
I'll take the first one because narrow versus broad is, something that's on lots of people's minds right now. So we have these superhuman intelligent systems, but as you mentioned, they operate on very narrow sorts of activities. It can drive a car really well. It can draw a picture. It can answer a question or translate language, but it can't do all of those things. Superhuman narrow is great, right? We want superhuman narrow things. We want a car that can drive better than a human. Absolutely. But we're also interested in broadening these things. But But what I want to kind of bring people's attention to is it's not entirely clear what we mean by broad AI. A lot of what we're doing in AI research right now is broadening the input space of an AI without broadening the output space. So what do I mean? Like some of these great new um, vision and painting and drawing systems from OpenAI and whatnot, they can
Mhm.
take in vastly more pictures and process them in interesting and useful ways and produce useful outputs. But it's still a drawing program, or it's still a machine translation program, or it's still a text generation program, right? We haven't broadened the output. We haven't gone to a system that can draw and tell stories and drive a car, right? So, but as we do that, as we do this broadening, um, yes, we are forcing AI systems to use concepts in lots and lots of different ways. So, in that sense, we are achieving something in greater understanding, according to this kind of the way I've been talking about understanding. Um, but it's still very limited, right? We're still very limited in the context that we're able to do with this knowledge. But as we broaden our AI systems, yes, I think we tend to also see a correlation with broadening of understanding.
That's a great point and very interesting point to end on. And I'm glad that you sort of draw that distinction and make that dichotomy, because I think that for a lot of the general public that isn't, in and out of this world and building every day, there's not that sort of awareness of the definitions and, like I said, the dichotomy between input and output. And I mean, this is all really fascinating stuff, and I'm sure we could keep talking about it for 5 hours, but I'm going to let you get back to your work. Dr. Riedl, thank you so much for your time and insight.
Thanks for having me. It's been a wonderful conversation.
Have a good one. All righty. So now I would like to introduce my co-pilot and fellow emerging tech brew writer, Hayden Field. Hayden is joined by Sasha Mojsilović, who is a IBM fellow, head of trusted AI foundations at IBM Research, and co-director of IBM Science for Social Good. Hayden and Sasha, the floor is yours.
Thanks, Ryan. And hi, Sasha. It's
Okay.
great to be talking today.
Hey,
Glad you could
Hayden.
join us.
Hey, Hayden.
So,
Thank you for having me.
thanks. So, yeah, no, really excited to get started on this conversation. Again, everyone, Sasha is an IBM fellow, head of trusted AI foundations at IBM Research. I'm really glad to have her here today. So, I guess let's kick off with the first question is very in line with the theme of this event. So, right now, AI systems are ultimately powerful tools for pattern recognition and from that prediction. So I know this is a near impossible question to answer, but based on the theme of this event, again, I have to ask, in your eyes, how far off are we from AI and cognition, and how are you defining that?
Okay, so I think I'm probably going to make many people very unhappy with my answer, but I think realistically, if you look at the systems of today, they are kind of done, right? They're very, very far away from the cognitive capabilities of human beings, and or at least they are far less intelligent than what people think or what they read in the news. And the reason is because for a long time, when we dealt with AI development and the tasks that we chose to attack with AI, we kind of focused on very narrow tasks like speech recognition and image perception and medical image diagnostics, and we got to these models that kind of have really excellent performance in those domains, but it's only one task. So we have these models that excel in doing something, and then because of that, we think that they're super intelligent, but they're not, because if you take a system, for example, that is trained to diagnose breast cancer, that very same system cannot diagnose skin cancer. Or you have a system that plays AlphaGo, but it cannot play chess, and you have chatbots that can help you buy wine, but then you have to retrain them if you want to buy shoes. Or they cannot do a conversational on a broad or a wide range of topics. So when you think about the human cognition, it's actually very multifaceted. It has things like, we make a representation of the world around us and we reason over that. We transfer knowledge from one domain to another. We learn with very little data. The current models, at least deep learning, needs millions of samples to get a concept right. So all of these bits and pieces in some way, shape, or form have to come together for us to be able to even scratch the surface of human cognition. And there is a lot of research. There is research in reasoning. There is research in knowledge representation. In our lab, we work very hard, for example, to start putting these things together. But this is just really very early. And I personally think we're still at the very beginning of being able to create capabilities that even remotely mimic what humans can do.
That makes total sense. And I loved your point about AI systems excelling at doing one thing, for example, and many people misinterpreting their intelligence. So to that end, let's talk about how we refer to AI systems, because clearly it's important. Some people say that in using words like learns and understands, we ascribe too much credit to these systems in the eyes of the public. Other people say that these words help make the technology accessible and easier to understand. Where do you stand on the language debate?
It's hard. There is this word intelligence that is at the center of things, because we get really sensitized because it's so uniquely human. So whenever there is a word intelligence attached to something, it gets overhyped, or we get very concerned, or we pay tremendous amount of attention to it, or inflate what it can do. The reality is that many things that we call AI today are the same old models that we used to call data science maybe 5 or 6 years ago. The reality is that many of the models of today are what we call machine learning, or specifically deep learning. So had we called the field machine learning, it probably would not have gotten that much attention, because it's the word intelligence that is, making us write about it and talk about it, and the worry that one day we might have a machine that is going to be better than the humans. But then the reality is that this whole thought of replicating or mimicking human thinking or human intelligence is not a new thing. I mean, people were obsessing about it since the dawn of humanity. Like Euclid and Aristotle are basically the fathers of reasoning. Leibniz was thinking about how do we rationalize human thought. There was this quest to create a thinking machine from whatever. We had Frankenstein. So this whole idea of replicating something that is uniquely ours is then something that makes people talk about it and write about it, and sometimes it's not really serving the field in the way it should.
That makes total sense. And you're right, the word intelligence is pretty buzzy, and artificial intelligence makes your ears perk up more than machine learning. That's probably why so many people throw AI around when they're pitching investors. So every year, a lot of time, money, and energy go into the journey, or to some fool's errand of developing artificial general intelligence. In your eyes, do you think those resources should be reallocated to shorter term, more practical problems in the field?
Well, it's hard to say, because it's always the balance, right? We need the moonshots. We need these great big ideas, because this is how we advance science and technology. This is how we make discoveries, right? So in a way, we maybe need this idea of AGI, because on the quest to make better machines, we make advances in AI. But on the other hand, that's not everything, because it's also important to focus on how we put these technologies to a really good use. And what are the kinds of applications, or what are the kinds of problems we are going to solve with all these technologies that we want to develop. So take, for example, language generation or transformers. And if you kind of go just Google what are the top 10 or top 20 uses for transformers, you'll find things like meme maker, a quiz producer, website mocker, designer, etc., etc. We played with generative modeling techniques for a long time with the ideas of, let's have something that will help us create news, or let's have something that is going to make better images of celebrities or even make music. And, making music is fine, but can we make better things? There are things that we need very badly, like new medicine. Like we're in the middle of COVID pandemic and we do have a vaccine, but we do not have a COVID therapeuticals. We need new materials. We need new fertilizers to grow food. We need carbon capture materials to fight global warming. So these are the kinds of ideas that I would like to see propagate or drive the research a little bit more, because this is where humanity needs help the most. Part of the work that I do and that what we do in the lab is looking at this notion of, how do we use AI to accelerate discovery? How do we use AI to help us create new molecules or new materials? Because these are the kinds of applications that AI can actually do better than humans, even though it's very narrow. And this is just one tiny, tiny drop in the universe of problems that we are seeing today, from inequalities, poverty, lack of medicine, lack of education, lack of clean water, climate change. And I think we may want to take a pause from obsessing over AGI and maybe think about how do we create AI solutions for these kinds of problems. I think that's a little bit more pressing than having a super intelligent machine that can beat us in, I don't know, whatever it can do.
Couldn't agree more. And speaking of driving research, recently you and I chatted about how it's important for technologists to ask honest questions like, where do humans actually need help and why? And how can AI help solve those problems? Can you talk about why those considerations are vital and why they could help prevent advancement solely for the sake of advancement?
I mean, I think they're vital because when we look at the history of human race, it was about solving problem. It was about making progress on building bridges and helping plow a little better or faster to make more food. It was about creating vaccines and medications and the penicillin. And these kinds of problems ignite human thought. Another thing that I think when we look at the field of AI for quite some time, and even today, a lot of AI scientists tend to operate in silos. And, I'm an AI scientist, I'm a modeler, I'm probably very good at producing algorithms. There are probably many people who do better job than me, but collectively, we can do it. But on the other hand, I don't know much about what it means to be poor or hungry. I don't know how diseases happen. I'm not a chemist. None of us are. So this idea of creating collaborations or motivating AI researchers to kind of get out of this cycle of back propagation or fantastic accuracy and things like that, towards understanding the problems around us. And that requires more than just an AI scientist. It requires us to work with others and study the problems together, because we can't create solutions for the problems that we don't understand. So one example is, I know you mentioned in introduction, we have our Science for Good program that we created for that very purpose. And the idea is that because we don't know these problems, we work with NGOs, we work with social sector organizations to understand where they have needs, what are the kinds of challenges that they're seeing in the field, because they are on the forefront of these problems. They can tell us how things happen. We understand the physics of that. And then you are a better scientist, you're a better AI researcher, because you're putting your skill and your capabilities in the service of a real problem, of a problem that matters to all of us, that matters to humanity, a problem that kind of makes this world a better place.
Definitely. Can you give an example of a time that, you know, one of those conversations led to a change?
I think I want to be kind of humble and recognize that these are really, really big problems. And I think it's very ignorant of us to say, okay, I'm going to go work on something, and 3 months from now or a year from now, I'm going to solve this problem. It won't. But one of the things that I'm really, really proud today is our most recent work on molecular generation. And it kind of started with this criticism of generative modeling, where we said, why do we want to create fake news and fake images when we can create molecules? So we sat down, and it was 3 years ago, and we developed architectures that just very recently produced the very first antibiotics that were created by AI. And we tested them in the lab, and they had really wonderful properties. And it's only the beginning, because we're now thinking about, okay, how do we now direct that to, last year we directed it to design of COVID therapeuticals. We're now thinking about how do you take that towards new materials. So it's a work that I'm really proud of. But again, I want to step back and say, hey, even though we had this fantastic demonstration, we are still very early on. It's still the beginning. And we need to be pushing more and working harder, and not just us, so many of us, because when we do that, that's how we go towards real discoveries and benefits for all of us.
Definitely. Well, great point to end on. And thank you so much, Sashka, for joining us. Really appreciate it.
Thank you. Thank you for having me.
And that's a wrap, everyone. Thanks so much for joining us today. You all technically made history with us as part of Emerging Tech Brew's inaugural event. So we're really glad you could come along for the ride, and can't wait to see you at our next one. Thanks.